So what do we have to repair today? Today we have this big Toshiba SA7150 problem with this unit this time. Only sound out of the right channel. So let's tear into this thing and see what's going on. I've had this unit before. I had this unit a year or two ago for another problem, and it's back. That's the problem with old electronics, is you can get married to these things very easy. But this one's a paying customer, so let's take a look and see what's going on with this big brute today. Okay, it tops off the amp, so we need to determine whether our problem is in the preamplifier section or if it's one of the power amps. Okay, you got two separate amplifiers on this left channel, and this one's the right channel. On the back of the unit there's a little bridging strap, well, these little plugs here, that connects the pre-out to the power amp in. So if you unplug them, you'll have no sound. So I'm just going to put my scope on to the left channel, and we'll see whether we have any audio going into the amplifier when I turn up the volume here. There's the left channel. So we do have sound going in, as you can see on the scope. So I know the problem is therefore something in the power amplifier. So let's just see whether we've got any power going through the amplifier at all. Make sure that we got signal getting into it, and do we have anything going through the amplifier? Maybe the problem is in the speaker switching. Maybe we have a fuse that is blown if this unit has speaker fuses. I don't know because I haven't opened the bottom yet. But let's first of all see whether we've got any power. But let's just poke around in the amplifier and see whether we have any audio signals on any of the others. Looks like we have audio here. Turn my gain down a bit. So we have on the left channel, as you can see, we have signal on our drivers. So I think this might be the test point here for outputs. Here we go. Yeah. So we have outputs here. These are our test points. So that tells me that the actual audio amplifier probably is working, and it's either a protection circuit, maybe a bad relay, or possibly there are speaker fuses on this unit. So let's get the bottom off it now, because they're going to be in the bottom. I don't see any fuses on the top side, so if there's any speaker fuses, they're going to be on the bottom. So let's get the bottom off this unit and just take a look and see whether we're going to be lucky and it's going to be something simple like a blown fuse. And that would happen. These units were very well protected because they were a high power amplifier, so they did generally protect the circuitry from things like a speaker wire shorting at high volume. They usually did protect the output stages with fuses of some type. So let's get the bottom off it and see whether the problem is as simple as a blown speaker fuse. Looking at the bottom of this unit, there are two fuses, but these are going to be main AC and DC fuses. I don't see any speaker fuses here. I'm sure the unit has them somewhere. They may be on the main boards. Here's our outputs from our transistors here. They go back onto the main board. It also has protection relay that kicks the speakers in when the voltage stabilizes. So like for example, when I turn it on, you'll hear a click. One click there, you'll hear another click in a second. That's the relay, the speaker relay kicking in. So typically how that protection circuit works is if there's any DC voltage, that allows the voltages to stabilize before it actually turns on the speakers. If there was a fault in one of the amplifiers that was causing a DC voltage to appear on the speaker terminals, it would kill the sound completely. So I'm still convinced that there probably is a fuse in here somewhere, but where they've hidden it, actually there's a relay on the board as well, so it might be down here. this brute weighs a ton. Literally, this thing's probably 70 pounds, 80 pounds. There is a relay down here. This will be the speaker relay. There's another relay up on this one, so maybe we have a bad relay. Let's just see. I can hear that relay clicking, and I don't hear this one, so we might even have a bad relay. Yeah, the other relay is kicking in. This one's not. This relay is not kicking in down here. So the relay on the left board is not turning on, so I have to investigate a bit and find out why it's not turning on. It's in protection mode for some reason. Do we have a DC offset, or do we have a bad relay, or something in that protection circuit is keeping the left channel from initializing and turning on the relay? So in order to work on the amp out of the circuit, I'm going to disconnect the wires that's connecting the board to the power supply. So we've got a yellow, a blue, a black, and a white wire that have to be connected. And then we're able to unplug the actual amplifier board. Put the screws back in so that I don't lose them. As you'll notice on this unit, it's two completely separate, these are what's called a monoblock design. So we have two filter capacitors here for the right channel, its own rectifier block. Here's the rectifier block for the left channel, and here are two filter capacitors for the left channel. So now that I've unplugged and disconnected all the wires, I can now lift the amplifier block right out of the chassis. And basically this has to be done in order to separate the driver board so that I can check and see why this relay is not working. So now we've got the board out, I can start to test components on here. Maybe we have a component open, maybe we even have a bad relay, it could be a bad coil. We'll figure that out, but now that I've got the board out, I can actually work on this separate. So as we run some tests on the driver board here, I just disconnected the relay coil because I want to make sure the coil's not open, so I'm just going to measure across the coil here. And I've got 600 ohms, which is for a 24 volt coil relay or coil, 600 ohms would be considered right about where it's supposed to be. We've also got a diode across here, which is okay. That's to it's testing fine. That's to absorb any kick back from the relay when it de-energizes. And there's a resistor here. It's a 1K ohm resistor, and I'm measuring 973 ohms, so we know that that's okay as well. It goes back into this transistor array. It's an IC. They call it Q803, and basically what it is it's just an array of transistors, and this is the switching for the relay. Not liking the looks of this because this part, if it is bad, is probably going to be hard to get a handle, get a hold of it. It's a SA7150. And if that turns out to be where the fault is, we may be running into some trouble trying to get parts for something that was made back in the 1970s. But we'll just run some tests on this thing and see what the problem possibly could be. Okay, just checking some resistor readings here. We've got a 22K resistor here. It's our 608, it looks like, 22K resistor. I put my meter across here and I'm measuring 1.3 mega ohms. I'll show you on the meter display here. So this is 22K, it's red, orange is the color, and as you can see, 1.4 mega ohms. Here's another 22K right next to it. You'll see it's measuring 21.92. So this resistor is open. Let's change this resistor, see if it fixes the problem. on this amplifier. I got the old resistor out now. We'll just measure it out of the circuit. It should be open. Here we go. That resistor is open. So that resistor shot, and looking at the circuitry, it's right here, and it applies, this looks to be the B- supply. It's a dropping resistor to take the B- supply into this transistor array. So one of a couple things could have happened. Either the transistor array itself shorted and that's why that resistor burnt up, or the resistor just could have got tired and failed. And that's what I'm hoping the problem is this resistor just got tired, and it's not burnt right up. There's no burn marks or anything on it, so I think it just probably got tired and went open. So I got a new one here. We're going to install the new one. So the new resistor is installed. We're just going to solder it back down to the board here. Clip off the excessive leads. There we go, new resistor is installed here, and we're going to now reassemble the board, install it back in the unit, and see if it works. So we reattach the 4 screws. To attach the driver board back to the heatsink. Again, nice amplifier design. This is what I like about working on these old units, even though they sometimes seem like you're getting married to them. That's because people that have these old units, they don't want to part with them. It's worth to someone who owns something like this, they know how good the quality of this is compared to a lot of the new products today, and they don't want to part with their old equipment. And I can't blame them. I've got an old Sansui myself that I'm hanging on to for exactly the same reasons. I know that I would never get one anywhere near the quality today. So I've got an old, in my collection of vintage receivers, I've got an old Sansui 9090, which I'm going to do a service video on it at some point. There's not much wrong with mine. Controls need to be cleaned. It hasn't been used in many years, so I'm going to do a video on that at some point. I just don't have a time frame as to when I'm going to do it, but at some point I will do one, and you guys will see it. Because that, like this, is a beautiful amplifier, beautiful receiver, and it's about the same size, same vintage, same power. It's just a great unit. Let me get the heatsink bolted back in, and then we'll hook up all the wires. Okay, the unit is remounted. We just put our plugs in here for our output transistors. We have the 2 plugs. We have the speaker output here, which is the white wire. This is the output terminal for the amplifier. So we'll reattach and try not to drop the screw. I should find a shorter handle screwdriver for this. I'm using one that's like 2 feet long. It's kind of overkill. But my other one is in my other workshop. Okay, we have our power wires. Be sure to match the right polarity, yellow to yellow, blue to blue. Otherwise you're going to have some major smoke when you apply power to it. So there's the yellow wire. These big capacitors, they have big screw down lugs. Like, talk about quality. This is second to none. And then the final wire here is the blue wire. That'll complete the work on the bottom. We still have some plugs to put in on the top to plug in the input and plug in the power supply. These are the power inputs from the power supply for the output stage here, and we've still got the power inputs for the preamp stage, which is fed on the top. So we're just gonna make sure that these are in nice and tight. We'll turn the unit over and plug it in. On the top side, we have our input, or sorry, this is our meter connector. And we have one more on the bottom, I forgot to. I've got the audio input. This is the meter. This is the power connector for the low voltage for the driver board, or for the driver board. We have one more, this thing weighs a ton. We have one more connector to go in on the bottom here, and it's this one down here. Oh, you guys can't see what I'm doing. We have one more connector to go in. It's this one right down here. This is the input connector, which is the audio input to the board. And it just plugs in just like that. Now, the moment of truth. I can test this thing and see if it works. I've got to get my main power cord and plug it in. And I do not have this plugged into my isolated supply because this sucker draws way too much power and it'll blow the fuse when it turns on. So that sucker is plugged directly in. Okay, volume down, everything ready to go. Power on. Let's listen for the clicks. And do we have music? Stupid me, what did I do? I have no sound on my left channel. What did I do? Think about it. I'll give you a little hint. I disconnected the relay. I unsoldered the relay for testing the coil. Don't! I didn't connect it, so now I have to get in there and resolder that relay, but I can get in there without having to pull the board, so let me do that and we'll test it again. So to do that, I'm just going to unplug the power from here so that there's no power coming into this board at all. And we'll just get the soldering iron and we'll get it down here and we'll just resolder that. Okay, that should do it. Okay, now, make sure there's nothing here that's got short circuit, like solder in it. We'll reconnect the power supply there and we'll plug the unit back in. Moment of truth. I'll turn this around so you guys can see both audio meters on the front here. That way you'll know. You'll probably hear the stereo sound anyway because I do have two speakers here, but power on. And there we go. Beauty, huh? Love it. That wasn't supposed to happen. My speakers were creating a little bit too much vibration on the shelf and just knocked some stuff down. Okay, this unit is fixed. Let's get it back together. So we'll just reattach the bottom of this unit, and then I can phone the guy that owns it and give him the good news that his big old Toshiba receiver lives to see another day. I think I've said it before, but I'll say it again. They don't build them like this anymore. Nothing these days is built to last. The old vintage gear is so nice, and it's so nice to work on because you can take things out like that. The amplifier modules, you can just take the separate module out, work it on the bench. It's all discrete transistors. I mean, it doesn't get much more serviceable than this. It's like working on some of the old VCRs from the late 1970s, early 1980s. VCRs, when they got into the 90s, started to become less and less serviceable with more and more plastic parts. But the old ones, going way back, were very serviceable. I've got some old Betamax machines that I'm going to dig up out of my storage unit, and we'll take those apart and service them for future videos because they always tend to attract a few viewers. But let me get the top on this thing. We'll give it one final test and then get it out of here. top cover goes on, and then the back cover, the tab actually, there's a tab underneath here that this slides into. So that goes in like that. There you go, one last look at the Toshiba model SA7150. One channel was dead. There we go, we're back in business. It was an open 22K resistor. Better hang on to this for the guy that owns it, because he's certainly going to want to know what was wrong with it. There we go. Little half watt 22K resistor. That resistor supplied the negative bias voltage to the speaker protection IC. That's part of the circuit that measures if there's any DC offset voltage present in the output before it turns on the speakers. So they have a positive and a negative supply. Basically what they do is they take a sample of the output voltage and look for any DC component and do a comparator. So the transistor array, which looks like an IC little flat pack, but it's actually just a transistor array. It's basically just a it's like a bridge type network, not a bridge rectifier, but like a Wheatstone bridge type circuit, using resistors that measures for any current and any offset voltage present on the speaker terminals, and if there's any DC voltage, it will not turn on the relay until. And what it does when you first power the unit up, normally when you turn on a big amplifier like this, there are some fluctuations on the outputs as the voltage is stabilized. There will be DC component present. Once the voltage is stabilized, it returns to zero. When that circuit determines it's safe to turn on the speakers, it energizes the relay and you have sound. There we go. Thanks for watching. We'll catch you in the next one real soon. Bye for now.